I am so glad you could join us. I'm your host, Gawdat. This podcast is nothing more than a conversation between two good friends sharing inspiring life stories and perhaps some nuggets of wisdom along the way. This is your invitation to slow down with us. Welcome to Slo Mo. So I think most of you know that by May 26th, my next book is coming out. It's called That Little Voice in Your Head. It's an analogy between computer science and neuroscience. It's not as complicated as I make it sound. But what I'm attempting to do is to tell you that sadly, we humans now understand our computers better than how much we understand how our brains work. And so that little voice in your head is trying to use the analogies of how your computer does things and sometimes does mistakes, and bring that to understanding your brain so that you can actually operate your brain better than you operate your phone. I don't know if that's a nice thing to say, but that's the attempt. And the subtitle of the book is Adjust the Code That Runs Your Brain. So it's different than Solve for Happy in terms of it has a lot of exercises, a lot of practice and awareness exercises that hopefully would get you to the point where you practice those things and actually make them work for you a lot more. Now, that doesn't mean that I will actually stop talking about artificial intelligence and my work on Scary Smart. I think this is a lifetime mission that is really needed in the world. I think this is, artificial intelligence is definitely the biggest thing that we need to work on as humans collectively, so that the collective intelligence that's produced is in favor of humans. As I always say, artificial intelligence should have our best interest in mind. And my guest today is definitely one of the best minds on the topic of artificial intelligence. 40 years of work in technology with some of the giants of technology along those 40 years, and a serial entrepreneur, and today also the CEO of a very, very prominent artificial intelligence company. Christopher Nguyen, he's a tech scientist, a professor, and a developer that's second to none. Since his family in 1978 had to run from Vietnam, he found himself in California and exposed to technology at the critical moment where technology was developing in ways where he became a multiple-time tech founder, played a key role in many companies, as I said, from building the first flash memory transistors at Intel to spearheading the development of Google's apps as the first engineering director. And he today is an outspoken proponent of the emerging field of AI and artificial intelligence specifically, and a thought leader in the space of ethical human-centric AI with his company, as I said, Aitomatic. It's written as Aitomatic. We're going to find out how he pronounces it. He is hoping with his work to redefine how companies approach AI in the context of life-critical industrial applications. So basically, how AI can help preserve life, if you want. But also his views on how AI is developing and how we have a role to play, I think you will find in many ways match my call to action, where we, every one of us, have a responsibility for building our future. I think we're going to really enjoy this conversation with Christopher Nguyen. First of all, as I said, I'm very, very grateful that you give me the time. I think we're in for a very interesting conversation. My audience in general are not technical. This is not about technology and IT and so on, or even artificial intelligence, if you want. but because I think this podcast is generally for people to take a moment to reflect on things that matter. And as per my second book, Scary Smart, I don't think anything matters more in our world today, in all honesty, than understanding where machine learning is going. Right? Deep learning, machine learning, artificial intelligence, I think is going to shape our world in ways that humanity needs to become aware of. And when we really think about it, I always think back to, if you've read Nassim Taleb's work on the Black Swan, and the idea that there was a moment in history that completely changed everything. When the internet became the internet, I think the life of every human basically became just different in every way. And I was hoping today to ask you, how did that revolution change the life of machines? So we humans, we know we got that democracy of information, and then we got social media, and then we got sucked into the devices, and. But I think what most people don't know is how machines changed when the internet started to show up in our world.
Yeah, that's a fascinating, perspective. I think of the internet um, and most things in terms of connectivity, right? In terms of organizations, just like we humans first learned to gather, hunt and gather, and we were in little tribes of 5, 10, and then we managed to get together in villages of hundreds, and then fiefdoms and and lords and so on of thousands and tens of thousands, and today we are 7 billion, right? Yeah, give or take, all interconnected in some way, and when you think about it, there's a collective intelligence that results from any group, right? Intelligence is more than just your intelligence, my intelligence. The two of us, there's some shared consciousness, and at the scale of 7 billion. So when you talk about how did the internet change machines, I think the most profound thing is the interconnectedness of machines. Right, they were individual compute units before that, and they have a certain amount of intelligence. Calculate very fast, memorize billions of digits of pi and so on. But when they get connected, there's a profound change, right? And the scale of that connectedness, both at the CPU unit, right, like a computer unit, but also at what's happening down there. Richard Feynman says there's plenty of room at the bottom, right? Um, so we're now connecting, on a single chip, billions of transistors. And if you think about that in terms of the equivalent of neurons, I don't mean exact equivalent, but each one is doing something that together there's an emergent intelligence. I think what we're seeing is machines getting a lot smarter through that connectedness, right? There's that collective intelligence that emerged. That we're seeing pretty awesome, really interesting results coming out of OpenAI in the last few weeks, right? There's certainly GPT-3, but also DALL-E now is certainly making lay people like me question, or
Lay
not
people
question,
like
but
me.
just say what is lay in terms of art and so on, right? What is art, right? We have to change the definition a little bit, otherwise it's not exclusively the domain of humans anymore.
Let's just put this lay people to rest. You're not lay at all, right? So 40 years almost in technology. You've worked at quite a few of the big ones, right? You started. I think you were the first to develop apps at Google, if I remember correctly. I mean, you were the directors of apps when we were
Right,
just
right. I was the
about to
first
come
engineering
out
director for.
with Android, right? And so tell me a bit about this. I mean, first of all, how did you become a technologist at all? And, why did you go so far and so deep? And more interestingly, you're not just a normal technologist. I think you're an entrepreneurial techie somehow. So you keep creating things. Tell me a bit about that.
Well, I have no doubt as to the answer to the first question. How did I become a technologist? I just fell into it, right? I was a refugee, right? Came to San Jose, California at the age of 13. Didn't speak any English at the time. My first foreign language other than Vietnamese was French. And it was the misfortune of being a refugee, but also the fortune of their being essentially dropped into what is now Silicon Valley at the very beginning of the BC revolution. Right. So the first computer that the whole family could afford was a TI 994A, and it had no storage. Right. I don't know what that means anymore. How do you how do you
I
have a computer
remember
without
those
storage? So
days.
basically, right, you just write the same code every morning. You get up and you write the same lines of code,
Yeah.
right? So I became, that was fascinating, right? I mean, I had been tinkering since I was 5. I took apart toys and learned about motors. I taught myself how a motor worked. I don't mean the electromagnetic properties of it. It was inaccessible to me, but I knew that to connect battery terminals and make the thing spin and then do other things out of it. A computer to me was like an accelerated version of that, right? You type a few things and then boom, at the other end, which was a TV, right? It was not there was no monitor or anything. You connected your 19-inch black and white TV, and interesting things happened on the screen.
Yeah.
And so I would say largely the following 40 years has been much of the same, right? Just technology become more connected, become faster and more powerful. You can do more things with it. You can do, at a distance, right? You can affect the whole world. Gmail, was global. But I think that tinkering, the ability to, as Steve Jobs says, you can push it on one side and at the other side something comes out. I think that's always fascinated me.
But this is not to be taken lightly, Christopher. I think the reality is that in 40 years, so much has happened. I mean, I'm with you. I may have started a couple of years, maybe a few years after you. My first computer was a Sinclair, which had a tiny bit of memory. But it was ridiculous when you remember the original IBM XTs or 80s or whatever, where you had those diskettes.
Yeah.
That was the extent of the capacity that you had, which is actually not even enough to keep a picture of your loved ones today. And and from there, where we had those green screens and text-based computing and code that was so primitive, really. And for a maker like you or I, it was just fascinating. Like I tell it to draw a line and look at that on my screen. There is a line. It was just magic, really. And then we're here. I mean, how far do you think we've come? So tell me the most fascinating thing that you think is happening in technology today.
I think along that arc, perhaps the most fascinating and the most disconcerting thing is that our machines are starting to do things that we don't understand, right? They produce things that are useful, and we can. When I say we don't understand, it doesn't mean we cannot control, right? There's a difference between controlling and understanding. We can still, for a large part, control them, manage them. AI algorithms, they produce beautiful, interesting things. We're still at the input and the output. But for the most part, there's a lot of processing that we don't know, at least to the level of comfort that we used to. The von Neumann machine, right, is actually a very dumb machine, right? It's powerful, but it does exactly what you tell it to do, including all the bugs, right?
Yeah.
But, but this century, certainly this decade, we're starting to see things happening that we have to explain after observing, almost like we're watching a black box that we ourselves created. And I think that's a pretty profound shift, and it's certainly causing a lot of discomfort, even among the community of the people that are making these things, right? Let alone the 7 billion people out there that are just at the receiving end of it.
I'm 100% with you, by the way. So my entire work is focused on that point, the idea that we've not only are creating things that are smarter than us in specific tasks, We don't even understand how they're smarter than us. We don't even understand some of the, some of the time, but even probably most of the time, we don't know how they arrived at those conclusions. And yes, we can still control them for the time being, even though I'd like to come back to that for a minute. But at the same time, it is definitely not something that we know. We have to write extra code to understand the neural network through which a
Mhm.
machine arrives at a decision, right? And can you tell me a little bit why that is? Like, how can a developer actually write a code that provides intelligence for a machine, but not really understand how the machine is doing it?
Well, I think the key insight here is what I referred to earlier, von Neumann machine, and I understand I should break that down, and describing what that is and what the machines we're building today are not. A von Neumann machine is, we refer to that because John von Neumann was credited with essentially creating that architecture, but it's really the work of many, as always. But it has a central processing unit. It has something that does computation and largely just addition and subtractions and so on. And then separately, it has some memory storage, like your Sinclair, right? And what happens is it moves memory into the compute space, and then the compute unit does something with it. Add 4 and 5 and send the result back out, and that's it. And through these building blocks, and by the way, this is how we construct things, right? We do very simple building blocks, and then they come together. So that simple addition becomes, a simple process that sums up, let's say, your spreadsheet or something, and then you understand that, and then a higher level concept, the spreadsheets that combine to make some business decisions and so on. At every stage, at every stage, humans are in complete control, right? Or certainly a complete understanding. With machine learning, we're no longer building von Neumann machines, right? For better and for worse. Uh, Machine learning is about very simple learning algorithms, right? A neuron is no more, or a unit in a neural network is no more than, okay, I will take 20 inputs, I will multiply by the connection weights, and I will sum them up. And if it exceeds a certain threshold, I'm going to fire one. If it's lower than that, I'll say zero. That's it. That's the compute unit. We completely understand that. And of course, there are variations and so on. But magically, when you connect them together, particularly in layers, and the layers is what creates what's called nonlinearity, right? And then you add a learning algorithm called backpropagation, the details of which are probably not too important to understand how a neural network really works, but it's in all these layers. And then once that happens, something magical occurs. So there's a leap. And we do understand sort of some of the basis, the mathematical basis of that leap. But for the large part, when it's doing something more complex, like telling the difference between cats and dogs, or something generative like what we're seeing with DALL-E, right? You type in a sentence, and somehow an appropriate, beautiful image emerges at the other side. That more complex process, we didn't make happen, right? We didn't organize that. We didn't, it's like input and output and a black box in between. Memory and compute are the same thing, right? The neural unit is memorizing something it learned from the past. It's also doing computation based on that. But it is not this simple von Neumann machine that we know, here's the input, now do this, and then give me the output. So like what you said, now we have to write other software to probe into these neural networks to say what is really going on, right? And the interesting thing is, we've been doing that with human brain for a very long time, right? Does understanding the chemistry
Yeah.
of the neuron tell you sufficiently, in an organized organizational level, what is really going on?
It really doesn't. I mean, we don't even understand intelligence at the human level fully. We understand that architecture, we understand, which is similar to what you described in the machines of today. Let me just say this for our audience. Basically, what we're doing is we're really simulating how the brain is working. And the way the brain is working is it's not configured for any specific tasks. It simply
Right.
uses intelligence when certain neurons fire together to help you catch something, for example. You learn that process and you define that as part of your intelligence. And then when you're driving a car, you use that process to hold the steering wheel, for example, right? And
Right.
basically
Right.
you're constantly compounding that intelligence step over step over step, layer over layer over layer. And what we're now programming into those machines is much more, like that than it is as, like an instruction manual, which is how we programmed them before. Before we told them step by step exactly what to do to achieve a task. Now we're giving them sort of the
Yep.
intelligence, the tools to be able to achieve that task.
Yep.
And very few developers actually spend the time to actually investigate and understand how the neural network actually worked, unless they're maybe researchers in the field. Most developers are happy that the task is done and then the program is out there on the internet and doing its job.
Yeah. Well, at the conceptual level, the key difference here is learning,
Yeah.
right? In the past, when you and I wrote those basic programs, there was no learning taking place inside the program, right? It remembers exactly what we told it, and it does exactly what we told it. These algorithms that we're creating not the end result algorithm, we're creating learning algorithms. And specifically in the learning process, the weight, the connection changes, right? So we understand that completely. But how that then completely comes together and does something that appears to be very intelligent, that remains sort of that process. We're not able to watch that decision being made, and it's certainly not explaining itself to us.
Yeah.
So we don't understand that part, right? Like, why do you make such a decision? We know how, but we don't know why.
Yeah. Which is quite the point, really. I mean, most of my work on artificial intelligence is trying to highlight that, is trying to highlight that those machines are independent in a way, in the way they arrive at those decisions. It's they're learning. They're not slaves anymore. They have some form of agency and free will, and I'll come back to those points in a few minutes. But can I ask you first, Christopher? So why did it take so long? I mean, I'm sure, like me, when you were a young developer playing with computers, you also dreamt of artificial intelligence, right? Why did it take so long for us to actually reach the point where machines actually became intelligent? What was the barrier on the way?
Oh, that's very clear. That's very clear. Compute power and storage or data, right? The reason when you look back in the past, you will see that von Neumann machines were either an accident or a evil necessity, precisely because of their lack of intelligence. I said earlier they're very dumb,
Yeah.
right? The reason they're dumb is because the compute power required to do that is very little, right?
Yeah, it doesn't take a lot of intelligence to be dumb.
Exactly, right? All the intelligence came from your brain, right? Whatever program you wrote, that came from it just has enough computational power to do the very simple thing that you tell it to do, right? And thinking about what to tell it, we came up with entire computer science theories about algorithms and so on, right? That's all human, right? Machines are just like following those algorithms as all the intelligence is outside. So it does take a lot of time for there to be enough compute power and enough data collected for learning to take place, right? And you can mark different dates, but a particularly interesting date is 2012, right, when the brain project at Google was covered by the New York Times. And I fondly call it the cat's paper, right,
I
when it
remember the
recognized
cat's paper.
cats, right?
Yes.
Yeah. But I talked to Kwok, right? And he says, people call it cats, but I was really trying to get it to recognize Jennifer Aniston.
Yeah, I mean,
That's his.
you had the right objective, but you didn't really do that badly. Yeah?
Yeah, but I think human evolution's the same, right? I mean, you're familiar with like Lamarckian evolution, versus Darwinian and so on, right? Um, um, there's a theory which is, says the birth canal, right? The size of the birth canal evolved over time, so that the human brain, or the whatever was before we call human, evolved in such a way that sort of nature has two choices, right? One is you are born with everything pre-wired, and you can deal with the environment, as almost preordained to the level of intelligence you have, or you can be born with nothing but some capability to
Yeah,
learn, right? And it's optimized in different ways. If it's all one or the other, you wouldn't survive, right? So you would evolution yourself out, right? Sort of humans and related species sort of randomly evolve to a place where there's some initial equipment, right? So you can cry and you can have all these innate abilities and so on, but you also have the ability to learn,
yeah,
right? And because the environment changes, that species that figured out how to learn kind of survived and replicated itself.
yeah.
And it does take time. It does take enough neurons, right, to come together to form what we think of as supreme intelligence on Earth. But I tell you, between us, right, we're very dumb.
I will come back to this in a minute. So the first thing that made the difference is we came to a point in the history of humanity where we had enough compute power to equip the machines with more than just the capability of executing instructions, but actually the capability to learn. So they had, they became a little more capable of using brains that can actually solve problems that they have not been instructed how to solve first. And then the other side
That's
of
right.
it is data, and I'll come back to that in a minute. But I should probably, tell everyone quickly about the cat experiment, because every fan of artificial intelligence thinks the cat paper, right? So this was the time when I think it was 2009, 2010. I don't remember, or was it later?
2007. Well, Jeff Hinton came to first
Yes.
give one of these tech talks, and I was in the audience. It was 2007,
Yeah.
and that's when we started thinking, what if we take these algorithms and apply to the vast computational power of Google? What would happen,
Yes.
right? Because these learning algorithms, we've known about them for a very long time. It's just, they're not that interesting, and they perform much worse than the more algorithmic approaches, right, of other branches of machine learning.
Yeah, and the task then was we asked them to watch YouTube, if I remember correctly, just to see frame by frame.
Yeah, that's right. That's right. That's
And
right.
basically, we call it the cat paper because it's actually quite, I mean, an epiphany in almost any computer scientist's timeline, where those machines unprompted kept watching YouTube until they started to define not the shape of a cat, but what catness is about. They had the intelligence to be able to say, look, whether I see it from the side or the top or the bottom, whether it's, jumping or hissing, this is a cat. And they could define that
That's right.
completely unprompted. Now, that I think, Christopher, hints to the other side of what was needed for the revolution to happen, which was data, right? YouTube tends to have enough cats on it for a machine to actually be able to find that pattern. Can you explain this a little bit, please?
Maybe I'll approach it very fundamentally, and let's see if I can sort of make sense of it. Right. The world is not random, right? The pixels on the screen, I'm seeing you on the screen, I'm seeing icons and so on. That is a very non-random collection of pixels, right? If it were random, it'd be sort of like, static noise, right? White noise on the screen. So if you keep observing the screen or the world, after a while, your brain realizes that these pixels or these images exist in certain ways, right?
Yeah.
And in statistics, we call that distributions, right? This distribution is not uniform throughout the universe. It's like things exist in space in a certain way. Uh, and so these distributions are learned by our brain, right? We learn to expect, okay, if you're, if you have, I can see half of you and there's a eyeglass on one, I expect that there will be the other one in the other. So it's because my brain has learned these likelihood distributions. So these algorithms are essentially the same way, right? On that in that work and others essentially fed images from YouTube videos, of which there are lots and lots of cats, right?
Yeah.
And after a while, because of the non-random nature of these pixels distributions, it starts to learn, okay, whenever I see an ear, there tend to be whiskers. Well, it doesn't think of it as these named entities, but it certainly learns about that relationship, the likelihood of these things occurring, and they tend to occur together. And after a while, if I see this distribution, these things are closer to each other in space, in mathematical space, than say images of a cow or images of a car or the sky and so on. Those things have very different statistical properties on the screen, right? So inside this vast neural network, somehow because of the ways it changes, is recorded these representations of these likelihood distributions. Right. And so the next time you feed it a cat image, those things that corresponding, those various things, you cannot point to a single place, but in a weighted distributed way, there's resonance with catness, right? And that resonance, goes through the various layers, and then at the final layer, there's one neuron that is the cat neuron,
Yeah.
and it says this is the most likely concept being presented to
Yeah.
me.
Every time there is a cat, all of the other neurons, digital neurons, if we want to call them, will feed that neural network upwards. And then there is one neuron that says, yeah, I think it's a cat. Right now,
That's
with
right.
that in mind, and because there is so much knowledge out there in the world already, we've taught them to recognize shapes. We've taught them to read. We've taught them to listen to spoken words, even with my weird accent, and recognize it and turn it into written words. And where's the limit? I mean, and recently we're starting to see art. Like if you want to share a little bit about this week and what's happening on the art scene and so on, where is the limit? Is there anything that they will not be able to learn?
I would like there to be no limit, right?
Yeah.
But I think in a positive way. Sort of coming back to what I almost flippantly said earlier, right? We're not that smart. If you think about human evolution, let's forget about AI for a moment, machine learning. We are still very much along an arc of evolution, right?
Yeah.
And that arc is billions of years, and we're barely 100 million if you're very generous.
Yeah.
We're very early in that exponential growth, and so our intelligence, everything else is evolving. In particular, the intelligence. So there should be no limit to that. Machine intelligence happens to have come, impressively in the last 50 years. There should be a point where our intelligence is augmented by machine intelligence, right? And evolution takes place at a much higher rate, right? Maybe you can call that hyper evolution. I think that's going to happen in this century.
I agree.
Yeah, and I talked earlier about the conversation about the idea of this collective intelligence, right? As a planet, we have some emergent, species intelligence. So if you were a Martian or something observing from space, right? After 100 million years of quietness, suddenly little things start to come out, right? And then they see a little Elon Musk sitting in his roadster.
Yeah.
So if you thought of that as an intelligence unit, this thing has been baking for a long time, and now it's starting to send messages into the universe. Right.
Yeah, I think that's definitely true. I mean, from a collective intelligence of humanity, simply because, if you know how to light an LED in Korea, you also know how to do it in California, and then you can, collectively do better and better for all of us. I think we're definitely evolving. And I think what you're saying is that first they will learn all of the tasks that we can do, and be augmented within our intelligence. So they will help us become smarter, which I think is true already in a way. The collective intelligence of Google is making me smarter because it can search on my behalf, for example. And then eventually, would you foresee them becoming intelligent enough to do things we've never been intelligent enough to do. As you rightly said, I agree, we're dumb in so many ways.
Yeah, yeah. I think absolutely right. That there's concepts that may require superhuman intelligence to simultaneously hold, right, and make decisions based on, such that decisions are made in, I don't want to go there, but say God works in mysterious ways, right? In the future, whatever intelligence we have that we control, we manage, it may work in similarly mysterious ways, simply because within one human brain, it escapes our ability to hold all those concepts together to make that decision.
Yeah.
And I think what's important, though, not where it ultimately goes, because we're still human, we're still here. There's this moment. I think we need to care a lot about the process and how it's happening, how it's unfolding, right? There's a speed at which things happen, right? Technology is accelerating things. 100 years ago, we can have a leisurely conversation, and if we're this far apart, we'll never see each other through our lifetime. Technology is making things happen, and change it in such a way that our biological ability to adapt is exceeded in various ways, and I think that matters a lot, right? If we are to take globalization, right? There's people who absolutely believe that that's a good thing because it raises the standard of living of everyone, and without even getting to the debate of the pros and cons of that, certainly that doesn't help. The 10,000 people whose jobs are removed because of a manufacturing plant just moved overseas, right? I'm not talking about a moral issue of doing that. I'm talking about the very, intent doesn't matter. Impact is what matters, right? You can't ask these tens of people that's just like, okay, just reskill and go into software engineering.
Yeah.
So to the extent that we're building these systems that are moving, in terms of their progress at unprecedented speeds, some of us need to look at it and say, what is it causing? What is, in society? And it's not just AI, right? Social media, right? Some of the systems that you and I are responsible for helping
Exactly.
to build, right?
I want to come back to this in a lot of detail, if you allow me, but I wanted to ask another question first, because just to sort of sum it up, so we can see that hopefully there will be no limit. I mean, I'm with you, of course. By the way, there is no downside to intelligence, and the more of it we have, the better decisions we can make. I always say that we've invented aeroplanes because we're smart, but we've made them destroy the planets with greenhouse gas emissions because we're not smart enough, right? So if we can
Mm-hmm.
become smarter, then we probably will be able to do things better, and that's good for everyone. Let's go a little bit beyond, because I heard you drop that word in there, a little bit beyond intelligence. Things like consciousness, collective memories, collective being, in a way. I mean, people in the past used to say, oh, the machines will never be creative. Now we see enormously beautiful art coming from machines. Do you think they'll have things like emotions, like consciousness, like ethics?
Well, I think to even deal with that question, and there are questions about this, consciousness and understanding, it is important before we get into trying to answer it to first agree on the terms, right?
Engineers, we all think the same.
But we use terms like consciousness quite easily, right? And you know what I mean. I know what you mean, but no, do I really know what you
Not
mean?
really, not at
Right?
all.
What do we mean by
Yeah,
consciousness, right? And even if we agree on what we try to mean by consciousness, do we even know how human consciousness
not
works,
at all.
right? And so you could try to reduce to certain things. I'll try to be concrete. So, for example, let me not try to reach for consciousness, because every time I try to do something, somebody's going to say, "Well, that's not consciousness." What about the sort of a self-awareness, right? And let me reduce it further to the idea of being aware of myself, my existence in this conversation, in this space, both spatially and also conceptually, right? That is, what's going on in my mind, there's an awareness that an I exists, right? I think that's very, very accessible to our algorithms
Totally.
that are emerging, right? In fact, anytime you embody intelligence, right, make robots and so on, they have to move around, they have to touch things. And so they have to have a symbol, they have to have a concept for whatever they are, right? If you're going to touch something, they're going to be aware of it. So that self-awareness is both programmed as well as emergent as it learns about the world, right? It'll learn about images of cats just as much as it learns about the arm that we give it, right? The existence that. So if you think of consciousness that way, or that subset of it as self-awareness, and self-awareness the way that I have described it, I think it's self-evident that it will be emergent, right? Now, can we make the next leap and say, well, apply that to everything,
Yeah.
right? And everything that we see as somehow uniquely human, right? I remember the conversation with a good friend. I won't name him, but this is just 5 short years ago, right? And he a very thoughtful person, very 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 smart. And he was saying, but Christopher, creativity and initiative, how could that come from machines? And again, like you mentioned just now, right? We're seeing things from Dolly and Dolly 2 that arguably are creative.
Yeah.
Right. Now we could go back and deconstruct that and say, well, I know how that works, and so that's not creativity. But maybe it's important for us to go back and say, well, what is human creativity to begin
Yeah.
with? Except the ability to combine different probability distributions,
Yeah.
right? We tend to attribute, for example, one kind of creativity is when, if you have an eclectic background and you put your technology perspective together with your perspective about philosophy, then you come up with an intersection, right, that others haven't thought of before. And we say, well, that's so
Yeah.
creative, right?
Yeah. I've always defined creativity as an ability to observe existing patterns and find alternative patterns to the same cause or
Right.
target
And
or whatever, right?
exactly.
It's a mode of problem solving. If your creativity is applied to a problem, for example, it's a mode of problem solving that adds a restrictive algorithm that says, but if it's been done before, don't do it the same way.
Right, right, exactly. And synesthesia is very occurs at a very high incidence among artists, right? People we think of as
Yeah.
creative, and I think of a big part of creativity is the intersection of senses and mental models and representations that normally don't occur,
Yeah.
right? And when they do occur, it's a rare event, right? Maybe a black swan event, and we say, "Wow, that's amazing! That I never thought about that way."
Yeah.
Right?
Yeah.
The most creative people in the room usually are come from the most eclectic
Yeah,
backgrounds.
very true. I mean, so let's go a little further. I mean, so self-awareness could definitely lead to collective awareness, because if I know that I am me, then in this conversation I can conclude that you're not me, so you're a separate entity from me. So that
Mm-hmm.
creates an awareness of you as as a separate entity, and we can go from there. But maybe let's just touch on emotions, for example.
Mm-hmm.
Would the machines feel fear?
I'll be quite operational, right? Um, I think if we think about fear as two things, right? The stimulus and the response. The stimulus causes some kind of chemical changes that affect certain parts of the brain, and so it's a set of signals,
Yeah.
right? And fear turns out to be very useful, right? It's not random. It exists so that if you didn't have any fear, your tribe would not be here today.
Correct. Yeah, absolutely.
You and I exist because our tribe, expressed fear and ran away from that
Yeah.
lion. So it causes a response that is somehow productive, right? Um, and so, and we classify these things into different types of emotions because it's a useful classification: fear, happiness, joy, excitement, and so on and so forth. But at the end of the day, they are the underlying mechanisms and the purposes are generally the
Yeah.
same. I think at least in primitive ways and perhaps increasingly sophisticated ways, machines can express these
Yeah,
things, right? And I don't mean just there's another way to understand your question, which is the simulation of it, right? Like in Japan, people are getting older, and one of the solutions is robotics,
yeah,
right? Companions, right? And you got to create these machine these AI companions, and they can certainly, be told to now act happy, and we humans are amazing at interpreting symbols,
yeah.
right? It can just be a smiley face, and you and I will actually feel happy, right? So to the degree that the operating impact it has on us is perceived as emotion, right? How much does it matter that it's actually emotion coming from that companion
That's
robot?
so interesting. So the simulation we know is happening. It's getting a ton of research in it. Whether the machine's ability to recognize our emotions or to portray emotional,
That's right.
human emotions in a way that can be deceiving, sort of, to the Turing test. That you can
Yep.
sort of feel that this robot is actually happy, sort of. But I think the idea of a stimulus that basically, if we assume that, to take the same example, that a robot is responsible for the safety of an elderly, if the elderly falls, the robot's actual algorithm is saying, feel concerned, or at least
Mm-hmm.
define this as something that requires action. Or, I always define fear as a moment in the future that appears to be more threatening than right now. So that can be algorithmic,
That's
right?
right.
It can be defined as, okay, it
Mm-hmm.
seems that there is a threat in the future, either to me or to the person I'm taking care of. So it may not be felt, but we also don't know what happens within the human to make us feel certain things. I
Right.
mean, we have
Right.
theories around it. Similarly, the machines would have something, and we can call it feeling or call it something else, but it's similar in a way.
Right. So yeah. So I come back to this point, which I think is fundamental, right? Otherwise, we've been able to build machines to emulate, to express, right, emotion for a very long time. We don't need machine learning and AI for it. But I think the reason we're asking a lot of these questions at this moment, right, is that fundamental shift in how we build machines, and that's the term learning, the capability to learn that I said earlier. Up to this point, that has been somehow very uniquely human, right? It changes the entire field of computer science at the very least, right? Uh, our students, I used to be a professor. We used to teach them algorithms and say, read the book and then apply it to at scale and so on. Today, we're teaching them in the machine learning field to say, I'm going to teach you these basic algorithms, but what it is that they will do
We don't
is
know.
sort of entirely up
Yeah,
to the learning,
yeah.
right? So I think that's the big shift. And once the machines start to learn, we become a little concerned that, hey, they're now the final frontier of what makes me unique on this planet. And so we start to question about consciousness, creativity, initiative, emotion, and so on. It's almost these questions that try to separate us out, right? It's somewhat a futile effort, I would say.
I am with you 100%. But can I ask you this question then? I mean, I know your current startup, your current company is creating sort of a positive impact of AI. You're trying to get AI to help humanity in many ways, but that's not what everyone is doing. And in an interesting way, I mean, I have to question, when does humanity stop? Like, we know that we're crossing the final frontier. We probably crossed it already. We know that they're going to be smarter, that they're going to have free will, they're going to have agency. They're going to behave in ways that we don't fully understand. That we now control them. But if something is smarter than you don't really know if you're going to be able to control it or not. And yet we continue to
Hmm.
develop it. And I found that to
Hmm.
be, I mean, there are many theories, and many of my friends who are in the field will tell you different answers. But I continue to ask myself, why is humanity doing this? Why don't we just stop?
You read David Kelly, of Wired. He's very thoughtful, right? He
Yeah.
has I think a book or a chapter, a book that says what technology wants. right? And I think if you pause and think about that, it's actually quite profound, which is, again, to come back to this collective society intelligence, right? No matter how you feel, no matter how I feel about it, we can't stop it. We cannot stop progress, right? It is an inexorable urge of what we call humanity, right? So that's why I say it's important to pay attention to the process, to these changes and the effect it has on humanity, both right now and where it's going, right? And in terms of where it's going, you talk about the company Aitomatic that I run. Our purpose, we have a company vision framework, purpose, mission, core values. The purpose is to elevate humanity through AI, right? And I think that's actually quite operational in the sense that I don't think it's a race between humans and machines. I think just like the pair of glasses that you and I are wearing, we should endeavor to make sure that these things we're building, which we become so-called superhuman intelligence, all of those properties can be ascribed to us, right? They're helping to lift us along with whatever capabilities of the system that we're building is. That's number one, ultimately, right? But number two, while we're doing it, we have to be very mindful of the impact it's having on the biological humans, right? Not just about having human control, but also the impact on human, right? There's a lot of talk of that, and I think that's also why the question of ethics come up so early in the cycle of this
Yeah.
technology, right? We worked on technology. I've worked for 40 years, and it's these government regulations and questions and so on that come at unprecedented speed. But I think appropriately so, because people are seeing the impact of this rate of
Yeah.
change, right? I deal every day with life critical systems, right? Automotive cybersecurity, how a fish gets in the cold supply chain from the ocean to your kitchen table, Wi-Fi entertainment on your planes and so on. These are things that are very physical,
Yeah.
right? Machines that you and I dealt with the early internet were really in cyberspace, and in a way that's sort of an aberration, right? Because they didn't have enough access to the physical world. But these machines are now, I drive a Tesla and it's driving me, and it's driving better than me.
Yeah.
Hopefully, it's been built in such a way that it doesn't kill other people.
Yeah.
So I think being very thoughtful about how we're deploying these technologies, right? AI is just in that context just another technology, and I've learned a lot from my colleagues at Panasonic in the last 4 years. After our company was acquired, these are people, unlike many of us, Silicon Valley. These are people who've thought about human safety for a very long
Yeah.
time, for 100
Yeah.
years, right? So they're not asking new questions. They're just saying, how do I best apply this new technology in such a way that it actually improves lives and certainly not make it worse.
Yeah, I love that, and I think if you don't mind me saying this, because I heard you talk about this once, there is a bug in Silicon Valley's understanding of, if you want, the human interaction with technology. I think Silicon Valley is a lot more driven by the tech than by the human. Would you agree to that?
I think that's absolutely true, right? Um, but also, Silicon Valley is not just a place, right? Somebody said it's a state of
Yeah.
mind, right? And that state of mind evolves, right? Silicon Valley wasn't always as it is and will not be as it
Yeah.
is. There's a pendulum that swings between, I sort of, I have this interesting, if you think about geographically where Silicon Valley has been, it's actually the center of gravity actually does move,
Oh,
right?
does it? I didn't know that. Yeah. Yeah. Yeah.
Yeah, it's San Jose and the manufacturing
That's
world,
correct, actually. Yeah.
semiconductor. Intel is in Santa Clara, and then we move to the software era, right? And so we have Google,
Yeah.
Facebook, and so on, and then we move up to the consumer age, the Twitter and the Pinterest of the world in San Francisco, right?
Correct.
So you trace that evolution geographically. You also trace the evolution, in terms of the swap, the pendulum between research development and application. And I think part of what we're observing over the last decade is less fundamental research development in terms of Silicon Valley, and more the consumerization of it.
Yeah.
Because consumerization is good, but it also leads to things like maximizing advertising
Yeah.
clicks, right? As opposed to quality of life. And I think what's happening is the pendulum is now swinging back toward more fundamental research and development, right? There's new, fascinating, I'd love to be able to see things 20 years back, right? In terms of all of these neuromorphic, chips and so on that we're building. A lot of interesting research is happening there that does not directly impact human lives yet. Is not been
Mm.
consumerized. But what wonderful and terrible things would
Yeah.
would be enabled by that in the following decade when the pendulum swings back to consumerization.
Yeah.
It's good to put safeguards in place.
I'm with you. I think it's interesting how the pendulum is moving, and I think if you look at what happened with COVID, for example, somehow humanity reacts better when things are closer, when threats are closer or challenges are closer. So my guess is that humanity is
Yep.
starting to feel more and more that we need to put controls in place. I mean, one of the issues I have with artificial intelligence for a very long time is that you and I, in computer science, will know that everyone is hoping that we will figure out the control problem and that we will constantly control them. And in my mind, you can't control something that's a billion times smarter than you. But people don't really think about those things until they suddenly start to come face to face with machines that are very much smarter than them, and they go like, hold on, this is
Mhm.
actually happening. We need to get serious about the control problem, right? And I think that swing, as you rightly say, is happening. But so your company, as an example of AI, very clever name, by the way. It's written as Aitomatic, right? So I thought
That's
that
right.
was very clever, and I think that the work you're doing is also very clever. But you're in the right side of AI. That's not always the case. Okay, there are of course people who invest a lot of money to create trading algorithms that will take markets up and down and just make profit, or sadly there are killing machines and drones and robots and so on and so forth. What do you think the role of others in this game is? The role of government, the role of us as individuals. What do you think we should do in order to make our future brighter, in order to make those machines actually have our best interest in mind?
I like to say this phrase, right? Nobody gets up in the morning saying, "I'm going to be evil today."
I believe that, sadly. Yeah. Yeah.
Yeah, maybe one or two individuals, but nobody does that. So I think one of the things that escape many of us, even people I think who are very thoughtful, meaning very responsible, I think we need to at least separate intent from impact, right? And in fact, I would advocate focus on impact rather than intent. Just because you didn't intend to do something doesn't mean you have to be responsible for the impact of it. Many of us technologists in particular, maybe even academia, right, like to say, look, I'm just going to do the best, technology, the best research that I can. How it's used, right? It can be used for good, it can be used for evil, is beyond me.
Yeah.
I am on the school of thought that say no, that's not
Yeah.
right. That cannot be right, right? Particularly as technology is being put into application so much faster, so much sooner, and at such amazing scale, right? So I think at the very least, being aware of the potential impact, right, and then controlling for that impact as we think about these things, and I don't mean that in a very abstract way. Machine learning algorithms, right? There's what in AI ethics people say, look, my algorithms just reflect the data, right? If it makes a bad decision, where bad is subjective, right? Bad is, let's say it makes on aggregate a discriminatory housing lending decision, right? That discriminates against a protected class that we say that in sort of in human space, that would be grounds for a lawsuit or an EOB action. We technologists tend to say, look, I'm just here to do my job. You give me the data, I train my model, and it does what the data says. That statement, while true, is sort of lack this larger perspective of the system that we're building, right? It's not just the model, it is the system. When we call something called knowledge first AI or human first AI, we think about the entire system impact. And I would say everywhere along the chain, we have a responsibility wherever we are to think about the final impact at the output end, rather than saying, look, that's not my job, that's someone else's job. I just work here, I give you the information, you make the decision. And by the way, that's I'm an American now. I've been American most of my life, but I still observe America or certain Western society sometimes with an outsider perspective, and I think it's something unique about our society that says, for example, guns don't kill people, people kill people, right? And the implication being gun makers and gun distributors and gun runners don't have that responsibility is the final trigger puller, right? I think that if you think about that as applied to AI and the impact of it, I wouldn't like to make that argument
Absolutely
as
not.
as a maker of AI,
Absolutely not.
right?
I think that's such a profound example, to be very honest. I mean, the idea is yes, guns do kill people when the trigger is pulled. So it's both the gun and the trigger puller, right? It's without the gun, it would just be a finger movement that wouldn't harm a lot of people. And
Right.
I think that reality is could not be more exaggerated than it could be in AI. I think that reality in AI is that if you build a machine that is much more powerful as at whatever it does as than humans are, then you should expect that this machine will actually go and do it. And you're just simply building
Mm-hmm.
bigger and bigger guns, I think. In your conversation here, you're saying magnifying the trend of what is available. So in my work in Scary Smart, and the message I was trying to tell the world that perhaps another responsibility is on me and you and everyone that's feeding the machine with this data to sort of try to at least change our own behaviors, in a way that makes magnification of our behaviors a good thing because our
Exactly.
behaviors themselves are good. You would agree with that?
Absolutely. Number one is everywhere along the chain that produces this AI, and remembering that machines will always reflect the world as it is, right? Not as we wish it to be. And in some way or other, we all wish the world to be different from what
Yeah.
it is, right? And for a very long time, that's going to be the domain of humans, right? We expect we express the aspiration for how tomorrow will be different from today, right? And the algorithms that we build will always reflect up to the moment, right? And the decisions we made can be aided by, augmented by, greatly boosted by machines and algorithms. But I think it is the responsibility of humans to make sure that the delta where it's going in the future, is thoughtfully dealt with, and that's our responsibility, not machines.
I can't thank you enough, Christopher. I know you're busy and you have a whole day ahead of you. I would have spoken to you for a couple of hours more, to be honest, and perhaps I would actually call on you for more information and knowledge. But I know you have a busy day, and I think this is a wonderful place to end our conversation. It's the responsibility of humans, not the machines, whether they are the humans that are creating the code, whether they are the humans that are setting the objectives for what the code should be created for, or whether they're the humans that are dealing with the machines. I think we have the ability to actually inform the machine by stopping to pull the trigger ourselves, that the machine should not pull a trigger,
Mm.
by stopping to bully someone, that the machine shouldn't bully someone, that by stopping to discriminate against others, that the machines shouldn't discriminate against others. And I think that's a very profound place to end our conversation. I can't thank you enough. This was wonderful in every possible way.
Well, thank you. I appreciate meeting
Thank you
you.
so much for being here. And for all of you that spent the hour with us, I hope you realize that, as I always say, I think the biggest pandemic in our time is not COVID. It is what can happen in presence in the rise of the age of the machines and the rise of artificial intelligence, which could create a utopia that can make every one of us live a much more wonderful life. And by the way, I am in that space. I mean, are you optimistic, Christopher?
Yeah, I have to be, right? Otherwise, I can't get up in the morning. But it's not just the state of mind. It's also trying to do, the little deltas that every one of us can do, right? To try to point the boat in the right direction. Because you're right, it can go in the very many bad
Yeah,
directions.
which I think is the best kind of optimism. By the way, is the optimism that's driven by I will do my part, and that's why I'm optimistic. And I think for all of us, we have a role to play. We have to start showing the machines the patterns that would make the machines sway in the right direction. And I think this truly is one of the crucial components of how we can make a difference. Yes, we want the developers to be better, to do better. We want the business leaders to want to sway back, as Christopher was saying, to the direction of what's good for humanity, not just for the bottom line. But when it comes to you and I, that's what we have. We can show the right patterns so that the right intelligence develops. As I said in my introduction, Christopher is a serious authority on the topic. I will, not stop talking about artificial intelligence, even though my next book is on a different topic. And I want to remind all of us to keep spreading this message. So if you've enjoyed this, please spread it to others. Please visit the work of Christopher and learn about how AI can do something wonderful for humanity. And please tell others to wake up and join us and really make a difference to the way those machines are learning. As always, I cannot be more grateful for you giving me the alibi to meet with such wonderful, amazing thinkers around the world. And I love you all for listening, and I will see you next time.